Alrighty. Happy Wednesday. Um, I had a couple people ask for some more time. They joined late or couldn't get the book or something happened here. So I didn't run these yet. So I'm going to actually push these ones out until next Monday because I don't want to have to run the report twice and punch in a bunch of numbers. Is that okay? No one usually complains about extra time. So let's do that here. But that means you have 4 chapters due Monday. Did I put the 22nd? Does it not read? Okay, I'm really tired here. Okay, now it. Okay, the website is also very tired apparently here. My daughter, who's 16, decided to start taking electives at the high school, so she's taking first and second hour classes, and getting to the school at 7 in the morning to drop her off is awful. So I'm going to be cranky for a while. Sorry, I have a lot of coffee, but I will get used to this new schedule eventually. So 4 chapters due by the 22nd here for Zybooks. Let me make sure I have the right book here. There we go. Okay. And how are we doing here? We have 80%. Okay, that's pretty good. 99% done for Xylabs. All right. Almost everybody here got everything done for chapter 1. Fantastic. Let's just keep up that energy for chapters 2 and 3 and 4, right? Come Monday. So if it's actually awful, please tell me. But I'd like to imagine it's good practice. And I keep telling myself that when everyone complains about how much work it is, that it's good practice. Um, Again, it's a 4 credit class, so expect about 12 hours worth of work per week is a good expectation for an average amount of time people spend on the course here. If you're going way beyond 12, please tell me. Let's have a conversation and figure out what's happening here. But 12 hours worth of work per week is normal, right? And you can complain about it, but I'm not going to feel bad if you spend 12 hours a week. Is that okay? All right, cool. Um, so we're actually going to get into the next chapter, right? Because I think we finished out everything at branching, if I remember right, on Monday. Is that right? Okay. I forget things all the time, so I'm always double checking with you here because I tell the same stories to everybody here. Um, so we can move into loops, which will be a lot of fun, and we'll use them on the next project, which will be really cool. So we can start loops, probably finish them up on Monday, and we'll be ahead for a little while here. We'll see. Eventually, we'll probably need to take a little more time for these weeks here, but if we're a little ahead, it's not going to hurt anything, I think. And then it gives you more time to do the iBooks anyway, right? Okay. So if we start loops today, iBook still won't be due until then the 29th here. So I'll put that in for chapter 5 right here. So we do that. The 29th for chapter 5. Chapter 5 due on the 29th here. Uh, oh, I have to set these as no submission. I'm sorry. Um, no submission. There we go. If I do that, then it won't ask you to turn anything in, and they won't be confused. Let me go change those real quick. Sorry. Edit. Oh, that one's a no submission. Okay. Yeah, that no submission. It was just that new one that messed up. No submissions. Yeah, good. All right. Awesome. Um, Everything going okay with the project? And the plans to talk about that one a week from today, right? So, first thing we do next Wednesday is go over the solution of the project. I can't take it late once I've gone over the solution. So, if you had any trouble with Git, let me know. Happy to hop on screen shares, meet with you during office hours. Worst comes to worst, you can email me your code if you need to. I hate that, but it's okay. If you get it to me before the due date, I'm happy, right? Don't let Git not working stop you from turning it in. Just get it to me somehow, and we'll be okay. Get it to me. I'm funny or not funny. Still really tired. Sorry. All right. And the syllabus quiz. Did I mention this to you? I don't remember if I did or not. It's just a 1 question quiz that you acknowledge and understand the academic integrity policy. This is part of my paperwork I turn in when I fail people for cheating, is that they knew about the policy. It was in the syllabus. They agreed to the policy, and then they still cheated. Okay, so my little CYA here for everything I have to turn into the dean's office. Um, sure. So 1 point for that. and I put it in labs. I don't really have a good spot to put it here, so it's just a 1 point thing. Just take that whenever. You just put your name in the box. If you have questions about the academic integrity policy, please ask me. Right? Up until the point that you turn it into Canvas, we're just having a conversation, and we can change things. You can go and add citations and things like that. Once you turn it into Canvas, you've asserted that it's your original work unless otherwise cited. Right? All work is assumed to be yours unless otherwise cited. This is academia. If you give me something with your name on it, I'm assuming it's yours. Right? And by turning it into Canvas, it puts your name on it. Right? So as long as you haven't turned it in yet, we can have that conversation. Happy to chat. Okay. Again, I don't recommend you use these ChatGPT kind of AI related tools. Um, it just does too much for you right now when we're still learning. Even this inline completion that PyCharm has, which is not a pro feature, I really thought it was a pro feature, does a lot of stuff here, which is cool. It saves a lot of typing, but sometimes it suggests too much. It's not the end of the world if you want to use the inline piece here, but I don't have it on when I demo things, and it might be better for you to learn with it off, but it's fine if you want to have that one on. Not worried too much about that one. All right, so we start up a new project here. New project. I'm putting it in my repository. Did I do weeks for this one here? I can never remember. That's 1501. Nope, that's the wrong semester. I should just get rid of that one. I don't need last year's fall repository. Okay, yeah, I did. Okay, so we're in week 4. That's right. I just kept adding to week 3 types. So we're in week 4 now officially, right? So let's make a new project for week 4. Loops, loops. Here in my repository, make the welcome script. Life is good. Don't create another Git repository. Inside of a Git repository, Git gets confused. All right. Did we play our random number guessing game already?
We did a random number thing.
Do we guess the number and they tell you too high or too low? Or we just picked a random. Okay, then we're going to play a game. It'll be fun. Everyone loves guessing random numbers. Um, that was one of the first programs I wrote on my TI-83 in BASIC. It was a random number guessing game because I was terribly bored in class in school. I get bored easily, it turns out. I don't know. I think I'm self-medicating. I might have ADHD, but if you drink a lot of coffee, it's like the same as taking Adderall, so I'm probably fine. Don't take any medical advice from me, please. Obviously, I'm not a doctor. All right. So we were going to import random because we want a random number, and we want a number to guess that. So a number to guess is random.randint. Let's do 1 to 100 or so, and then we're going to get a guess here right from the user. Guess is a input of guess a number 1 to 100, and we can check, hey, if the guess is equal to the number to guess, print, you guessed it. Elif, if it wasn't equal to, now we probably don't need the else here because we're going to check too high or too low, but it's ever so slightly more efficient to have this here because it doesn't need to look at every single if once it finds a match. Again, we're not running this a million times. We're never going to notice we've saved half a millisecond, but it's ever so slightly more efficient. So you want to go too high or too low first? Too low? Okay, so if guess is less than the number to guess, we'll print too low. And if it's not equal to and it's not less than, it's got to be too high. So we don't need another if here. It's just an else, right? It's either equal to, it's less than, or it has to be the third option here, print too high, right? What does it not like about number to guess? Expected type string got an int. Oh, it's warning me here. Hey, dummy, you're comparing a numeric type to a string. You probably didn't mean to do that. Now Python's going to let us do it. It's never going to do what we expect it to do. An int of an input. Yeah, so let's do that. An int of an input here. And now that warning goes away. See, PyCharm is so nice. I totally did that on purpose to demonstrate that it's helpful. Let's try it, right? So we can guess a number, 1 to 100. 50. That was too high. Oh, shoot. Let's try again. 40. That was too high. Oh, let's try again. 30. That was too low. Okay, let's try again. 35. Too low. All right. 38. Too low. 39. Too high. Remember, it's a new number every time. It's pseudo. So it was a bad game here, right? Not very interesting. Now, what we could do is we could copy paste this a bunch of times and have them guess and guess and guess and guess and guess. But my favorite rule of thumb when it comes to programming is anytime you have the same code twice or more than once, you should feel bad about yourself because we can do better. Now we're learning how to do that. Okay, so don't feel bad. But from this point on, you get to feel bad about yourself if you have the same code twice because now you know a way to do better. Okay, so we're going to use a loop. A loop says, "Hey Python, do the same thing over again." It'll repeat here. So far, the only thing we've ever done is go from this line to this line to this line to this line. Then we added branching. So you got this line or this line, but it kept going top to bottom, right? There was no way to go back up here. But now a loop says, okay, let's rerun this thing here. So the first loop we're going to look at is a while loop that says, while this thing is true, keep on running. So what we want to check here to keep on running here is while we didn't get the number right, we want to keep on guessing, right? So we're going to say while my guess does not equal the number to guess here. Now, if it's not equal to the number to guess, it's either then too high or too low, and now all of this has to hang off of this while loop. So I grabbed it all and hit tab. So you can grab multiple lines and tab and shift tab here if you want. You don't have to do it one line at a time. So if the number is not equal to the number to guess, it will tell me too high, too low. Eventually, this will no longer be true because you did guess it right, and then I can just print out you guessed it, right? So outside of the block of code here, I'm going to have a you guessed it. So let's try it. So guess a number 1 to 100. 53. Too high, too high, too high, too. Oh, shoot. We have an infinite loop. This is never not true because I never asked you to guess again, right? We should ask them to guess again so that at some point they have a chance to get out of this loop. If they never have a chance to get out of the loop, you wrote an infinite loop. So I guess technically we have this one line here twice. Don't worry too much about it here. I don't feel bad about the one line here, right? But copy pasting, if it's too high or too low, 7 times in there, so you can guess 7 times, that we should feel bad about. So now we just keep on going. So eventually guess changes here. So it's really important that you change what's in your condition. And all this is a Boolean expression, just like our if blocks had some sort of is this true or is this false? Right? It's a Boolean expression. If it's true, the loop runs. So this is a pre-test loop. If it's true, it runs. When we get to the end of the block here, and it's all done, check again. So when it gets to the end of the block here, it comes back up to the top and says, hey, is it true? If it's true, it runs again. You get to the end of the block here, comes back up, true, run again. If it's true, run again. So when it's no longer true, which is a double negative here, so when guess is not equal to the number to guess, so you guessed it right, and this is no longer true, the loop stops running. And then the rest of my code will continue on as normal. So if we ask them to guess again, now we have a more interesting game here, right? With 53. That was too high. What should we try next? 40? That was too high. What should we try next? 22? That was too low. Getting closer. 30? That's too low.
35.
35? Too high. 34? Too high.
14.
14's too low. 33? Too high. 32? Oh, sorry, 32. Hey, we guessed it with 32. We got it. Very exciting. Right? If we run it again, it's not 32, right? We looked at this random thing here. We get a new sequence of random numbers here. Very exciting. So, I'm sorry? It could have been. Yeah, we had a chance of it here. The chance is probably pretty low, but that's okay. It could have happened. So this loop then lets me run this over and over and over and over and over until it's no longer true. So I don't need to have the same code more than once. If I want to repeat something, while this is true, we use a while loop, which is nice. So it's going to check to see. So it's possible you guessed it the very first time and this loop never runs, right? If I put a breakpoint in here and I run it with the debugger here, have I shown you the debugger yet? The debugger is your best friend. It pauses your code when it gets to this line number. So let me stop there. Let me go back here then, sorry. So on the left-hand side where these line numbers are, you can hover over them and you notice this big fat red dot shows up. Notice it's not on every line. It's not on the lines that have no code, right? You can't stop at a line with no code. But a line that has code on it, here like guess here, will pause and will show you behind the scenes what's happening in Python, which is super cool. So I can hit pause here, and it says, hey, the number to guess is 31. Here, we can even go and change this number here. We can set the value if you want here. Let's set the number to 42. Now, I get a couple new buttons here we don't have before. Most of the time, we're going to do step over. Eventually, we'll get into the step into. Don't worry about it. Most of the time, we step over. It says run that line of code, and it will run one line of code at a time here. So if I step over, I come back to my console. What number do you want to guess? I'm going to guess 50 here. And now it comes back. Hey, the next line ready to execute here is line 8, right? So we can go, I want to step here. Guess does not equal the number to guess. I can go back to my threads and variables here. So my guess was 50. The number to guess was 42. Run that line of code. It's not less than, so it goes to the else block. It prints out too high. Comes back to ask for another guess here. Comes back to my console with guess 42. Go back to my threads. Step over. The while loop is done. Now the next line to run is 18. It prints that out, and we're done. But we should probably add in like some colons and spaces here, right? Make that look a little bit nicer. Colon and space here, right? That'll be a little bit prettier output. Sorry, I think my sugar's high right now. That's unfortunate. This also makes me cranky. There's a lot of things that make me cranky. I'm sorry. All right, just a little. Okay, not bad. Okay. So that's one thing we can do with the while loop, right? Remember we looked at validating some input? We said, hey, was this the thing we expected, yes or no? And then we had to hope on the second try they got it right. Well, it turns out we can use a loop for that, right? So how about we have a thing that says, let's do a play again equals a y, and while play again equals y, let's start a block of code, and let's take all of our code here and hang that off of that while loop. So, hey, do you want to play again? Will take me back to the top of my play again loop here, which is, hey, let's guess a new random number. Pick a new random number, have them guess it. So what I need to do then, so it's not an infinite loop, we'll have a play again equals an input of, do you want to play again? And again, I'm going to suggest a y or an n here, but I don't know what they're going to give me. They could give me, yes, they could give me a capital Y. They could give me garbage, right? They could give me the number 1. I don't know what they're going to give me here. So if we want to validate their input here, we can say while play again does not equal a Y, and play again does not equal an N. Right? Those are my two valid options. So if it's invalid, right, it's not this valid option and it's not this valid option. We're going to and those things together, because if it is a Y, this is false, this is true, false and true is false, the loop doesn't run. If it's an N, this is true, this is false, true and false, the whole thing is false, it doesn't run. If it's the number 1, this is true and this is true, true and true, yes, my loop runs. They can't get out of this loop until they give me a Y or an N, right? Which is nice. So then we just have to prompt them again. We could give them another message too. Maybe we'll print these to only Y or N if we wanted here. We don't have to, but sure, why not? Give them some more messages here. All right, so let's guess a number 1 to 100, 50, 25, 37, 43, 40, 38. All right, we guessed it. Do you want to play again? Yes. Enter only Y or N. Y. Enter only Y or N. 1. Enter only Y or N. Yeah, let's play again. Yes. All right, let's guess another number. Do you think it's 38? 38? That was too low this time. Okay, 50, too low. 75, too high. What is it? 60, I forget. Too high. 55, too low. 58. Hey, we guessed it right. You want to play again? Yeah? I heard a yes first. All right, what number are we guessing? Since you wanted to play, you can guess.
72.
72? Too high.
31.
31. Too high.
26.
26. Too high.
13.
Too low.
19.
Too low. What? 20? Too low.
24.
24? Too high.
22.
22. You guessed it. Yay. So exciting. But now we're validating their input here. So loops can be used to validate input. which is really nice. Now, doing this is a little tedious here, but it's only two options, right? We could put them in a tuple and say if it's not in the tuple, that's pretty common in Python. So if I have my valid options, I think we looked at that once, right? So maybe I have a list of valid options equals a tuple of y and n here, right? And then we said, while play again, we could say it's not in valid options, right? Because if it's in the valid options, then we're good to go. So yeah, this is slightly faster. I think I prefer this here, right? That's probably nicer. And this is easy then if we have like 7 different things you could pick from. Hey, here's the menu. What do you want to serve at your party? You got this thing or 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 this thing. Sure, we have one quick way to validate it here. Now, you're not required to validate things for the project, right? We're just getting started here. We haven't looked at how to do that yet. I wasn't sure we'd even get to loops right away, so I wasn't going to ask you to validate things. You're more than welcome to, and I will when we do the project just for fun to demonstrate it. But there's no points on the rubric for that, right? And go look at the rubric here for the project, right? You get 2 points for asking how many guests and including the host, right? Points for your pizzas, points for your salads, points for your 2 liters, and then just tell them to try. This is just a single if else here. Right? This doesn't need to be a loop here. Like try again later means like run the program again. If you wanted to do a validation loop, great, that's even better. But at this point, we're just expecting an if is valid, keep on going. If it's not valid, tell them please try again and don't be stupid. Right. Okay, that was all we were expecting for this one here. Sorry if that wasn't clear. Um, but now that we've talked about validation loops and you have a week to get it done still, feel free to add them in. It's not going to hurt anything. Or feel free to skip it. Either way is okay. But we do need to tell them it was valid or invalid. Right? We told you pizza, salad, or 2 liters. Why are you trying to serve ice cream? We don't have that. Sir, this is Wendy's. Okay. Actually, they do have ice cream, which their machine works way more often than the McDonald's machine for some reason. I don't know what Wendy's secret is here with that keeping their frosty machine running. But the one at McDonald's like always is broken, which is so sad. All right. So validating with a loop makes me stuck in here until I get valid options. Great. A loop of do you want to play again? Great. So I just keep on doing something over and over and over. A loop on, hey, did I guess the number or not? Right? We can use loops in a lot of different ways here to make the same thing happen over and over and over again. It's lots of fun. Um, let's see, other things we might do with our loop. So what if we were to ask the user to pick the top number here? Because that's much more interesting than 1 to 100. Maybe they want to guess 1 to a million because they're incredibly bored in class and they just want to zone out and keep typing on their keyboard. Sure, why not? So we can do that. So we can have a, I don't know, max number then is an int of an input to the max number to guess, right? And we go from 1 to max number, right? And then we don't guess a number 1 to 100, we guess a number 1 to max number, right? Everything else is still identical here, right? Does that work? Let's try it. So how high should we guess a number? How about 1 to 10? All right, 1 to 10. Let's do 5, 3, 2. Hey, we guessed it right. You want to play again? Yes. What's the max number to guess?
22.
42. All right, guess a number 1 to 42.
13.
13. Too high.
7.
Too high.
4.
You guessed it. Very exciting. Oh, we forgot to change our prompt for this one here. I guess over here. Let's change that prompt. There we go. Guess to max number here. Cool. Now, we could do a bad thing here if I gave you a negative number, right? That's a valid integer. Probably not going to do what we want here. So maybe we validate max number, right? So while max number is less than 1, right? Or less than or equal to 0, right? You probably don't want to guess to 0 either, right? Let's enter the max number to guess. And maybe we tell them print positive or greater than 1, a number greater than 1. You can give them a nice message here, right? So, hey, if I want -5 because I'm silly here, it doesn't work anymore, which is nice because, again, some people enjoy breaking programs because it entertains them here. That's fine. Right, so 5 is okay, right? So, I don't know, 2. Hey, we guessed it in the first try. Look at that. 20% chance that I get it. Very exciting. Now, we might also want to protect them against themselves here and be like, hey, if you want more than a million, you've probably done something stupid here. So we could put a max in, right? So we're saying there's a min here. We could say, or the max number is greater than a million. Now in Python, remember we can use these digit separators here. So in a literal number, I can put in underscores. Did I show you this early on? I didn't. This is my favorite thing in Python. Other languages don't have this. So the underscore character gets ignored. So you can do stupid things like this here. And Python will literally just strip out the underscores, but it lets you put them in the right place here and say, oh, hey, here's my digit separator to make life easy for humans to look at my numbers. Because honestly, like a million without the digit separators, ugh, that's gross. Like I have to look at this and count how many zeros there are. And most of the time I have to highlight the number of characters because I'm slow. There's three more, right? So we can use an underscore in our literals here to do a digit separator, and Python just ignores it, which is beautiful. So we're saying greater than 1 and less than 1 million. Now, you can't use commas, which is a little sad here. Python gets confused by commas because we comma separate things, like in tuples and lists. But the underscore character, they decided is perfectly fine for digit separator. I don't know who decided it, but someone did, and we will take advantage of that. So we can do it here, and it's beautiful. Um, and is it in Europe they use the decimal? They use a dot, and then they use a comma for like cents? It drives me crazy. There's a way to format that automatically when we do number formatting. Like, remember we did like the point 2f. If you want a decimal place, you would do comma 2f to do a comma separator instead of a point separator. Silly things like that. You can do the European formatting if you want here, which is okay. But now we have a max number. So our validation loop here says this is invalid this way, or it's invalid this way, right? It's not. I don't want to have a list of numbers 1 to a million and say, okay, it's not in the list of numbers 1 to a million. That obviously sounds like a bad idea, right? And it's numbers. We can do numeric range. We can do relational operators and say, hey, is it less than or greater than? Life is a whole lot easier. Nothing stops me from making a list with a million numbers, though, and saying it's not in the list, right? With programming, you've got 5 different ways to do whatever you're doing here. If it gets the job done, it gets the job done. Now, some are just better because they're more readable and they're faster and they're more efficient. That's better as the art here, but you can still get the job done. And that's what matters, at least at this level, right? So in 1501, we're just learning how to solve problems with code, learning what code looks like, how to write code that Python can understand, and code that you can understand, code that I can understand, and code that your fellow classmate can understand. We're going to write good looking code. Right, 2001 next semester, which I also teach, unless they get rid of me, which is fine. They can get rid of me if they want. You're stuck with me again next semester if you continue on. We do more of the same. We start talking about what makes something faster or more efficient. Start introing the topic, and then you get into 350, which is everybody's favorite class, data structures, algorithms, and analysis. It's a fantastic class. You're going to love it. That's how do we make things fast? Looking at algorithms, the speed of algorithms, analyzing algorithms, and looking at advanced data structures, ways of storing things in memory, doing fun, efficient things with them here. That's the more of the sciencey side of things here. I'm glad I don't teach that one because I like the art side of things. I like making the computer go beep boop bop, and all my computers are fast enough to run my programs nowadays. Like I'm spoiled here, right? We can store billions of variables and not run out of space here. We can run things millions of times, and it happens in an instant here. So, all right, we can validate ranges. We can validate inputs, right? Yes or no's. We can check things like that. We can use loops to repeat over and over and over again. So we got different things we can do with loops, which is a lot of fun here. Um, Another kind of loop now. So these are while loops. So they will pretest here. So this is a pretest. Oop, did I put that in here? Oh yeah, I did. Oh, pretest loop. Okay, good, 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 good. So it might not run. Now in this case, I know this one will run because I set it to yes to start, right? So I forced it to run at least once here. You might not want to play again here, but we have the option, which is nice. The other kind of loop we're going to run into in Python is a for loop. So a for loop says I want to do something for each item in a collection. And we've looked at a couple collections. Remember, strings are collections of characters. Lists are collections of items. Tuples are collections of items that are immutable. Dictionaries are a collection of key value pairs. Right? We looked at a couple of those early types here. So a for loop says, give me each item out of that collection. So if I have my name is an input of enter your name here, and we say for letter in name. So we use the in keyword, and it's no longer the membership operator. It's not asking, is it in here true or false? It's saying for each item literally in this collection here. I don't know why we reuse the same keyword, sorry, but we do. So we say for item in collection. So this is for item in collection, right? So the collection is our variable name, right? And the item here is some variable name. It doesn't have to be letter. It could be A, it could be Apple, it could be Eric, right? I like naming it whatever it represents here. So it's a individual letter because I know this is a name. It's a string here, right? So I get each character out, each letter out at a time here. We're going to print the letter, right? So this will run once per letter. So if I give it a Eric Chinesky, it will run 15 times, right? 4 plus 9, oh, I'm sorry, 14 times plus the space here. Chinesky's 9 letters, right? One per letter. Not very exciting here, but it does that. If I just give it Eric, it does it 4 times, right? So whatever is in that collection, it iterates over is our technical term for it. It's iterating, going one at a time. The first one, the next 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 one. And what we can see if we put it in debug mode here, again, debug mode is our favorite, we get to see that letter is assigned the individual character. So now letter is E, right? That's the first letter. The first time this loop runs, letter is E. And then I'm going to step over, and it says, okay, give me the next one. Now letter is R, and go to the next one. Letter is I, go to the next one. Letter is C, go to the next one. It's done. So for each item in that collection, we did something with it and we're done. Now, we can do some silly things here. We can say, hey, letter equals letter.upper here. We can change the value of the letter here. So now when I print it out here, I give it Eric and I get all uppercase Eric here. It hasn't changed name. So if I print name here, you didn't change the value of name here. You just changed the value of the letter that you were looking at in name. Okay, that's not super exciting here, but if we were to go through and make like a list of letters here, so we'll make some list, I don't know, call it our alphabet, right? Is a list of A and B and C. I'm not going to type them all out here because that's going to take way too long here, but we'll do the first 5 here, right? So here's my alphabet. I can say for letter in alphabet. We want the letter to equal the letter.upper. We'll uppercase that letter, and it'll print the letter, and we're done. We're going to print alphabet. Print the alphabet. So this is a list. It's mutable. We should be able to change these things, right? Because lists are mutable. Strings, you know we can't change individual characters. We looked at that string indexing. They give me character 2 out. We can't go change the value of character 2. But I could go get one character at a time if we wanted. So give it name, and we get alphabet, A, B, C, D, E, but it stays lowercase. So an important thing to know when we're iterating over a collection is you're essentially getting a copy. Essentially a copy of the item. So when you ask for, you say letter and alphabet, it gives you a copy of this thing here. It gives you a copy of this thing here. It gives you a copy of this thing here. We didn't go through and get the index out where we could go change it. We could say, hey, alphabet at index 2, right, the third thing, because obviously we start counting at 0, like all normal people do, right? 0, 1, 2, 3, 4. I tried teaching my 3-year-old to start counting at 0, and it pissed my wife off. She wasn't like actually angry. Maybe she's like, don't do that. And make them weird. But everybody counts from 0, right? All right. So if we wanted to change individual items, what we could do is we could loop through by index, right? So we've got a couple options for that here. So here's the alphabet here. So if we wanted to loop through by index, we know it starts at 0, and we know it goes to up to, but not including the length. Right? If there's 5 things there, there's indexes 0, 1, 2, 3, and 4. There is no index 5. So I could say index equals 0, and while index is less than the length of my alphabet here, I can take my alphabet at the index here and assign it the alphabet at the index dot upper. Okay, take whatever was there, uppercase it, and assign it back to where it was. We operate from right to left. So the thing on the right happens first, and we assign it to the thing on the left of the assignment operator. not the equal sign. That's an assignment operator. Sure, we like calling things different names. So that doesn't confuse anybody. Okay, so now this one will change the value here of alphabet because we're assigning it by index. Changing the value here by index. Um, what is it waiting for here? Did I do it? Why is it waiting? I don't know why I was waiting here. Why was it waiting? That was weird. Oh, I have a while loop here. Is this ever not true? Does index ever change? No, so I just wrote an infinite loop. So I changed index 0 a zillion times here while we were waiting, right? I need to take index and add 1 to it, right? To make sure that eventually it's no longer true and we don't have an infinite loop. Totally did that on purpose to illustrate how easy it is to have infinite loops, right? Infinite loops are bad. They make us sad and confused. Let's try it again one more time. Now we get the uppercase alphabet because we went through and we changed it. Now, doing this in a while loop totally works, but there's an easier way. So there's a cool thing we can do in Python here. I'm going to just do it up above this one here. We can say for. Now, there's a built-in operator called range. So range says, give me a list of values up to, but not including this number. So range of 5 will give me 0, 1, 2, 3, and 4. It works out really nicely here. So if I print range of 5 here, I get, oh goodness, it's not technically a list here. Sorry. So if I tell it, hey, I want it as a list here, then it'll turn it into a list for me. So ranges aren't actually, I always forget they're not actually lists here. Sorry. Now we get 0, 1, 2, 3, and 4. Right. So it's basically a list, but it's not actually a list. It's a Python minutia detail that no one cares about. Um, so I can get a range of values, which turns out if you want to range over the length of something, you'll get all the indexes out. Right? So if I range over the length of my alphabet here, right, I'll get 0, 1, 2, 3, and 4, all my index values. So ranging over a length of a collection is very common because it gets you all the indexes out here. And then what we can do, because it's essentially a list, I can say for index in the range, the length of this collection. It seems really wordy here, right? We're getting the length of the collection, turning it into a range, which gives me 0 but up to but not including that value. So I'm always going to get every index out. Most people that you run into in the world will put I in here. I standing for index. That drives me nuts because I'm easily irritated. So I will always write the word index out. No one else in the world does that, but I do it all the time because I enjoy that and it makes it, I think, more readable here. So you'll always see me write index. No one else does it. If you see I everywhere, it's okay. Just smile and nod. They're just being lazy here. Index is a much more proper term here to use. Right, so now I can say alphabet at the index, right, is equal to alphabet at the index dot upper. I'm sorry, goodness, not dot, at the index with the square brace notation, dot upper. There we go. Okay, so this here does the exact same thing of this loop, and because it's a for loop here, it's not going to be an infinite loop. It will run once for each item in that collection and then stop, which is really nice because it keeps you from doing stupid things like I did and writing an infinite loop and forgetting to do your increment so that it no longer becomes true at some point. So this is the most common way people will range over a collection if you want that index value to make it to change what's there. If the only thing you're going to do is read the value or maybe change it once but you don't care if it stays changed here, you don't need to use the range of the length of anything and use the indexes, right? You can use this. This is essentially like a read-only loop for all intents and purposes. It's mostly a read-only loop. We'll get into things when that's not necessarily true, but for now it's just called a read-only loop, right? For item in a collection. For index in a range in a collection, we can go and do something with that index value now. We can do much more fun things here. So uppercasing again is not very helpful, but that's okay. It's not the end of the world here. So I can use my for loop to go over items in a collection. mostly indexes here, because that works out really well for us. Uh, so other fun things we can do with loops here, because we're having so much fun. Let me go. Let me do it up at the top here, so we don't have to keep going entering my name every time here. So I'm going to make some art. Do you remember ASCII art? We can draw a picture of something with a bunch of characters. I'm not good at it. I can do shapes. So let's do a rectangle because that's probably pretty easy. And we'll use the star character because that's easy for us here. So if I want to make a rectangle, I need to know what's your width and what's your height, or length and width, or I'm going to call it rows and columns because that makes my life easier. I think thinking of it in terms of rows and then columns. I like grids. So I'm going to call it rows. So we'll have a rows then is an input of enter the number of rows for a rectangle, right? And then we'll have columns is an input of enter the number of columns for a rectangle, right? And we're going to do a loop. We're going to say for, now I want, for every row, I want to do something. So I can say for row in range rows. So if you say 5, I'm going to get 0, 1, 2, 3, 4. Right? If you say 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So I'm going to just range over. So this way I do something this many times here. Okay. Now I don't actually care what the value of row is. I'm going to ignore the value of row. I just want it to happen row number of times. Right? So I'm going to print, I'm sorry. And then what I want to do is I want to print the number of columns. So I'm going to say for column in range columns. What we want to do is I want to print a star character. Now, one of the fun things you can do in Python is we can change what happens with print. I think Zybooks covered this. I skipped over it because it was kind of annoying. So if I don't want it to go down a line here, I can say, hey, end with nothing. Don't end with a new line character. Change what you end with here. This is changing the behavior of print. I think Zybooks went over this. Did it? No? Maybe? Anybody get that far? Okay. It might have. If not, hey, it's a new thing. So it doesn't go down a line now. So this makes it not go down a line after printing. Okay. What I want to do then is after all the columns have been printed, now I want to go down a line. Right. So at row 1, I want to print 7 stars. Print, 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 print. Then I go down a line. So I'm ready to print the next row. Right. And I just repeat this, and that's it. Right. Now I have a nice, pretty looking rectangle. Let's give it a try. How many rows do you want for your rectangle?
6.
6. And how many columns? 4. Oh, goodness. Strings can't be ranged. Int of an input. Int of an input here. Totally did that on purpose. Int of an input here. And you'll run into these issues too when you're writing your code where you forget to do something. Perfectly normal. So 6 by 4. And look at that. 6 rows, 4 columns. Now, Python's smart and lets us do other things here. We don't technically need to do this. We can like take star times columns because Python lets you multiply strings, because isn't that normal? But we're setting ourselves up here to make life easier later in just a minute here, okay? So we can do a rectangle, right? Can we do a triangle? Like a right angle triangle? Like here, like 1 star and then 2 stars and then 3 stars and then 4 stars and then 5 stars and on and on and on. Can we do one of those? We can do one of those, right? Of course. So we'll get I don't know, is that the height of a triangle? So height is an int of an input here. Enter the height of a right angle triangle. Okay. And then we want to say what for every row, right? So for row in range rows, or height here, right? Now, how many stars do I want to print here? Right. At the first row, sorry, I should put that back here. I wanted how many stars? So at row 1, I want 1 star. At row 2, I want. At row 3, I want. At row 4, I want. At row 5, I want. All right, we're bored now. All right, I guess we're bored at 3, maybe 2. So I want to print some number of stars based on my row here. So for column in range, the row plus 1, right? Because it's going to start at 0. So I want 1, when row is 2. It's actually at index 2, or I'm sorry, because we're ranging, we get 0 and then 1 and then 2. So I want to just add 1 to that row. I want to print, again, I'll just steal this here, print out a star. And eventually, when we're done with our columns, let's go down a 1. Now again, we can do the string multiplication. I'm just going to avoid that because multiplying strings seems ridiculous. It seems like something we shouldn't be able to do, even though we can. All right, so let's give it a try. Actually, I'm going to print out a couple more prints here real quick, just to keep these separated. Oh no, after my prompt here, right? Print and a print. Okay. Somewhere in here, I just want to make it look a little prettier here. So what, 5 by 4. All right, height for our right angle triangle. 6. 1, 2, 3, 4, 5, 6. So pretty. And then just another print here, just to keep things separated. We okay so far with ranging? So again, we're using range. Now this time we're actually using the value here. This range, we don't care what the value of column is, right? This one, we didn't care about either one of them. We just wanted something to happen this number of times, right? Let's row happen rows number of times, right? We're throwing away this value here. Now, generally, if you're going to throw away the value, the convention in Python is to use an underscore to let someone know you're throwing it away. I sort of like calling it row because it's like more clear to me. I know what a row is, but again, either way is okay. You can use the underscore to throw. So if you're getting generated code, it's going to use the underscore because it's a throwaway value. Most people don't do that, especially at this level. So if you give me code with underscores in it, I'm going to look at you really funny. Like, did you write that? Because that's a pretty clear clue you didn't write it. Right? Just like if you post text out there and you have the M dash, the really long dash, that's a really clear sign. ChatGPT wrote it. There is no character on our keyboard for an M dash, but ChatGPT loves it for some reason. Have you seen that? Okay, M dash in GPT generated content. It's a whole thing here. The telltale sign you use ChatGPT and a trick to avoid it. Thank you, ZDNet. Plagiarism today. Plagiarismtoday.com? Who? What? Sure. RollingStones.com, the ChatGPT hyphen, or M dash is RollingStone.com. We got to go to that one. That's got to be a good source here, right? A grammar lesson from RollingStone.com. ChatGPT didn't invent this punctuation mark out of thin air. Human authors have used it for centuries. This is an M dash. It's a long dash. Haha, they're funny.
Automatically do that if you like the spacing just right, it'll burn it.
Yes, you have to. Best word M dash. Attic.
I've seen that before in order.
Convert hyphens to M dashes or N dashes. It's enabled by default. A word followed by 2 hyphens, then another word will convert the 2 hyphens into an M dash. So if you have dash dash hyphen hyphen, again, we don't have a key for it on our keyboard. That's how I know people don't write it here. Sure. Look at that. So some people are saying it's not AI generated. Microsoft Word did it to me. Don't think I'm fake. And they cry their crocodile tears. Just I get so many posts nowadays from AI generated nonsense garbage. And then people are hosting like, look, I run an AI generated bot and I get so much revenue. I get all this engagement here from my AI generated crap. You're like, you're just cluttering up the internet, making it worse. It makes everybody sad. And if you were actually making money, you wouldn't sell this idea to other people and make them pay you for your amazing idea that was making you money, right? Because you would just be making money and you wouldn't have to take other people's money. So people make me sad a lot. So anyway, okay. How did we get there? The M dash? What was I even doing? I don't even remember. Oh, the underscore character. That's not something you put in your code. I remembered. Have the power of coffee.
You were saying that sometimes instead of remote,
Yep.
be like that.
In underscore. So not a dash, an underscore. So underscore is the convention for throwaway. It doesn't matter. We don't use it. Yep. Yeah. That's like anonymous or just, yeah. So again, I don't like it. I generally will avoid doing that. Next semester, when we get into 200, the book author does that a lot. So I just want to throw it out there, keep it in your pocket. But I'll try not to do it because I find it confusing. Um, it's just one of those weird Python things. Okay, so we got loops. Now, another fun thing we can do with loops here, right? This was a right angle triangle. What about an equilateral triangle? Can we do a star and then a, oh my goodness, I can't line it up. Stop trying to be helpful. That's too many. No, one more. Delete space. One more row. What about that? Can I do an equilateral triangle? 1, 3, 5, 7, 9. Can we print out one of these? Now, to do that, we need to find some sort of relationship between stuff. So with a height, or I'm sorry, a base of 9, we have 5 rows. With a base of 7, we have 4 rows. With a base of 5, we have 3 rows. So let's actually just kind of look at it here. I would draw it on a whiteboard, but that doesn't show on the camera very well. So we'll just pretend here. So if we have base of, we'll start with 3, we have 2 rows. With a base of 5, we have 3 rows. With a base of 7, we have 4 rows. With a base of 9, we have 5 rows. Okay? So is there some sort of relation we're seeing between the number of stars on our base and the number of rows we have? I've done this a bunch before, so I know the arithmetic, but there's some quick arithmetic you can do.
So, so we're 35.
So the previous number of rows, that starts to get confusing. So 7 is 3 plus 4, 9 is 4 plus 5. There's something there, but I feel like coding that's going to be hard.
Um, that's all right.
How about base of 11 is 6? Base of 13 is 7.
I can see a pattern. I always know how to map it.
What's the pattern?
I mean, like you kind of already pointed it out. You take the 2 and the 3, you get the 5, 3 and 4, you get the 7, 4 and
Okay.
5, 9.
All right. So other than that pattern, do we see something else?
This goes up by 2 rows. Yeah.
So what's the relation between that then? So if how do I get from base to a given number of rows? This is increasing by 2. This is increasing by 1.
Well,
Yeah. So it's double the number of rows minus 1, right? That's what you said. Can we do the opposite? So what's the opposite of double minus 1? Is half plus 1. So halved plus 1, right? 3 divided by 2, throw away your decimal. 1 plus 1. 5 divided by 2 is 2 plus 1. 3 plus 1, 4 plus 1, 5 plus 1, 6 plus 1. Yeah, add 1 and then divide by 2. Sure. Yeah, either way, right? So, okay, so now we know how to get to our number of rows, which is good. So if I want a base then is an input, int of an input, enter the base for your equilateral triangle. Okay, and then my rows then will equal, we said base plus 1 divided by 2. Is that right? Yeah, force some order of operations. Thank you. Thank you very much. And now, Python's fun here. If my base is not odd, I'm going to get floating point number, right? If it's odd, I'm always going to get an integer. But if it's not, weird stuff is going to happen, right? So we can do our floor divided by 2, integer division, get rid of the decimal place, right? Think we looked at this one once, maybe? So this will make sure we always get an integer result here, which is good. Okay, and let's just comment that out here. I think there we go. Control slash lets you comment a bunch of stuff at a time here, which is nice. So now I have my number of rows. Now, how many spaces do we have here, right? Because I have to print out some number of spaces before I print the star here. So when I had uh, at row 1 here, how many spaces are in here? Well, there's 1, 2, 3, 4. Right, so this is 4 spaces. And then how many spaces does this one have? This one has 3 spaces. This one has 2 spaces. 1 spaces, 1 space, sure. right? And this one has 0 spaces. So how do we get from the base to the number of spaces? Right, my base here was 9, I had 4 spaces. If the base here was 7, I'd have 3 spaces. If the base here was 5, I'd have 2 spaces. Some more arithmetic, it's okay. This is the puzzling part. We have to figure out how to solve it in English before we ever start writing code. Because if we can't solve it in English, we got no chance of making code work for it. So when the base was 9, I had 4. When the base is 7, I have 3. When the base is 5, I have 2. Should we write that out? So base is 9, spaces is 4. When the base is 7, spaces is 3. When the base is 5, spaces is 2. The base is 3, the spaces is 1. So we see a pattern here?
What is it?
Divide by 2. Floor divided by 2, right? So base, floor divided by 2. Right? Drop the decimal place. Right? 4, or minus 1 if you want to subtract 1, right? And then divide by 2, but you don't even have to minus 1 because floor division gets rid of that for us. Right? Now I have my number of spaces. How many stars do I start with? 1. Easy. And what happens every row with stars? Goes up by 2. What happens every row with my spaces? Goes down by 1. Awesome. All right, so we know our pattern here. So I can say for row in row, range rows, I'm going to do something, right? Now I need to print my spaces and then print my stars, right? So for space in range spaces, let's print a space character and change the end to nothing here. And then for star in my range stars, let's print a star character, change the end to nothing. When that's done, go down to the next line. Now I need to change my number of stars. Like I said, spaces goes down by 1 and stars goes up by 2. Right? My little shortcuts, my combined assignment operators, take away 1, add 2, and then go to the next row. Go to the next row, and go to the next row, and go to the next row. Let's give it a try. 5 by 5, 5 right angle triangle. All right, base for an equilateral triangle. 10. We got 9. Right, even numbers are. So let's actually validate that it's not an even number, because that's going to screw things up for us here. And we can do more validation loops. So while my base, how do we check if the number is even? Modulus 2, yeah. If we divide it by 2 and there's a remainder, if the remainder is 0, it's even. Right, print odd numbers only. Numbers. Sure. And then try it again. Right, so validation doesn't have to be even within range. It's invalid if it's even. Right? Let's try it again. 5 and 5 and 5 and 10 was odd numbers only. Okay. What number should we give it?
13.
13? 1, 3, 5, 7, 9, 11, 13? Looks great. We did an equilateral triangle with a loop. Again, ranging over a number means I'm going to do it so many times. Right? Here's a predictable number of times. So if I know how many times I want my loop to run, it's probably a for loop. Or I'm going over items in a collection, it's probably a for loop. The while loops, it's really hard to validate stuff with a for loop. You really can't. Because it's not a set number of times. You don't get 10, maybe you get 10 tries and I just give up on you until you go away, stop using my program. But we probably don't do that, right? It's until you give me something correct. So until you give me something valid, you get to keep trying, right? Or like our silly game, until you guessed the number right, you stayed in the while loop. So we have different uses for the different loops, right? Now, anything a for loop does, we can do with a while loop. But for loops are easier, they're a little more convenient, and they make sure we don't have infinite loops, right? So a lot of times we'll prefer for loops for things, but we could do everything with a while. You can't do everything a while does with a for loop, though, right? They're not exactly interchangeable. That make sense? All right, cool. So we'll play more with loops on Monday and do a lab on loops on Monday, and then that about covers the chapter. Should we look at Zybooks and see how we did? I didn't actually open the chapter yet. while loops examples, counting, for loops, counting with range, while versus for, nested loops, we put a loop inside of a loop, developing programs incrementally. Break and continue, my least favorite keywords. These are perfectly valid keywords. I would assert that it makes code harder to read and understand and follow. People disagree with me, and that's perfectly fine. But we'll look at them, and you'll probably agree with me and say, "Oh, that's really ugly. I hate this." And yes, I think it's really ugly, and I hate it. Um, this loop else we'll get to, and then enumerate is a nice little shortcut too. So we got a couple fun features to look at Monday. Some other fun stuff, more advanced Python things. Dice statistics is one of my favorite examples ever because I love dice. It's definitely not tattooed over my arm here. All the fun dice shapes. We can do fun things with dice. All right. Questions, thoughts, concerns? Awesome. Get a couple minutes back to your day then. Don't forget about the project. Again, get it to me, ideally with the Git workflow that we like, by the start of class next week, Wednesday. If that doesn't work for you Wednesday morning and you're freaking out, just email it to me, get it to me somehow, and we're perfectly fine because I can't take it late once I've gone over a solution. Okay? Remember, projects are worth a whole lot of your grade here. Right, 30%? I have to double check. I think 30% of your grade comes from these projects. But there's a rubric. If it does it, you get the points, right? So you should know if it's working or not by the time you turn it in here. So you should feel pretty good about getting a good score. And one of the things I asked you to do is give me a self-assessment. Does it do this, right? Did it ask for the number of guests? And does it count the host, right? That's your hint. Don't forget yourself. You need to feed yourself at parties, right? Did it calculate the number of pizzas and costs correctly? Well, how do you know if it did that? You have to be able to work it out on paper first to check, hey, if I put this number in, this should be the output, right? You need to figure out how to test it yourself here by here's an example input, here's what I expect to have out, right? Remember, we need to be rounding up. You can't buy 2/3 of a pizza. Go to a pizza shop and ask for 2/3 of a pizza. They'll look at you funny, right? Be like, what, you want me to eat 2 slices before I give it to you? And they might actually sell it to you, but it'll be full price. Right? Yeah.
So, projects, the user know wants a free break.
Yeah, so it only needs to, every time they run, it just does this one or this one or this one, or tells them you picked a bad one, go away, or try again, like run it again, right? Yeah. So what are they serving? Pizza, salad, or pop? Those are our only options here, right? Okay, you're serving salad, right? How much does a salad cost? Right? Calculate how many salads you have to buy and tell them based on what it costs here. This is what you expect to pay for this number of salads, right? Okay. Again, ideally, this is an easy start. In my estimation, this is an easy start. Right? Based on everything we've covered so far, all the examples in class basically get this done. We just need to change some of the words around. Right? Is the thought here. Okay. Anything else? Awesome. Well, you have a good rest of your Wednesday. I will see you next week then.